Okay, let's go ahead and get started. So the topic of today's deep dive is a bit of a look under the hood of the TripleO Undercloud. So James and I are going to co-present this one. I'm going to start off with some more overview level material, and then James is going to dig a bit deeper into some of the mechanics of how the Undercloud customization works and some of the some of the lower level interfaces. So this is intended to be interactive. So if there are questions as we go through, feel free to stop me, and we can answer questions as we go through. So the Undercloud, basically, as most people will know, TripleO is all about deploying OpenStack on OpenStack, and so the Undercloud is basically our management node. It's a single OpenStack environment, like an all-in-one OpenStack node. At the moment, we only support one. There are no sort of technical reasons why we couldn't have multi-node Underclouds, other than the fact that the install tooling we use is currently just designed around configuring a single box. But anyone who's familiar with OpenStack should find that Undercloud piece is quite familiar. The services are all just standard OpenStack services with very few customizations. We configure the services via Puppet and a few scripts, which you'll see as we go through. There are kind of a few special cases which aren't currently handled by Puppet, although we have been moving more and more in the direction of having everything configured via Puppet over this cycle. But we kind of make heavy use of heat. That's kind of probably the first thing you encounter when you start dealing with TripleO. We have a heat installation on the Undercloud, and you pass templates in that define your OpenStack cloud, and heat does the orchestration around all of that. And more recently, during the Newton cycle, we've been moving towards using Mistral, and this is a workflow component of OpenStack. It's pretty nice because heat doesn't do workflow. It's a declarative modeling tool, and Mistral dovetails in pretty nicely there. We can use Mistral to provide the workflow pieces that we need, and it also provides an API. So if you want to have deployment expressed via a REST API, and you're not necessarily consuming it via a Python client, such as some consumers of TripleO, Mistral provides us with a good entry point for that. Another pretty new piece is Zakar. So we're using this for messaging, and in particular, it's useful for status reporting to the UI, and more recently the CLI. And then kind of the crux of doing the bare metal provisioning is we use Nova, backed by Ironic. So again, if you've used TripleO at all, you probably will be aware of this. But that's basically the sort of the paving machine we use for doing the bare metal deployments. And then we use Neutron kind of in a bit of an unconventional way, I suppose, because we're dealing mostly with bare metal nodes. We use Neutron to provide overlay network definitions and then do IP address management. Effectively, we use Neutron ports to give us the IP addresses that are then used to configure the network devices on the nodes. And so, again, fairly familiar to anyone who's used OpenStack before. We use Glance to store images and then do image-based provisioning via Nova and Ironic. And then another fairly recent piece is we've been using Swift more heavily. So not only to back the Undercloud services, but also as a place to store introspection data. And more recently, we've been pushing template data and other sort of deployment artifacts via Mistral, and we're calling that a plan. So if anyone's been following the Mistral API development, you'll be aware of that. And then there's Keystone. It's kind of a bit of a underused component in the Undercloud, because we really only support one actor, which is an admin user. In the future, if we support multiple overclouds and potentially even multi-tenancy, that would be of more value. At the moment, Heat makes use of Keystone for some credentials for the instances, for the nodes to signal back and things, but otherwise we don't make heavy use of Keystone really. So this is kind of just a visualization of what things look like back in Mitaka. So here you can see the services I just described. The Heat templates get passed into Heat, which then drives Nova and Neutron, which then drives Ironic, and then that does your deployments. And this is an illustration of the newer components, which I just mentioned. So layered above what we had before, we've got the Mistral workflow component, and then we've got the TripleO client CLI, which is being ported over to talk to Mistral at the moment, and then the new TripleO UI, which is one of the first major users of the Mistral-based interfaces. And again, I haven't got Zakar on this, but Zakar is being used in that workflow as well. And I've got a couple of other boxes on the left here, which just show that the nice thing about having Mistral in the mix here is it gives us a way to interface with other tools, non-OpenStack tools. Any kind of any third-party tooling that wants to be able to talk to a deployment interface rather than directly to Heat. That's going to be a good access point for those. So underneath you can see the Overcloud nodes. We won't talk about that too much today, seeing as we're focusing primarily on the Undercloud. So then when you go through and look a little bit deeper, this is kind of digging into the way which we use Mistral. I've talked about that a little bit. Under the hood, you've got the Mistral API, and behind that there's kind of two concepts to be aware of, and we're going to be making increasingly heavy use of this. We could probably have another whole session on Mistral, but I'm just going to dig into it a little bit today because increasingly people will need knowledge of it, and it's fairly new. So basically you have Mistral actions, and there's a lot of these built in. That's one of the values of using Mistral in the first place is it basically auto-generates Mistral actions based on, say, Python Heat client and Python Swift client. And so you've got a lot of built-in integration with OpenStack services that we're able to leverage. And then in addition to that, we've also got some bespoke Mistral actions, which are basically just Python plugins, and we're maintaining those in TripleO Common. And then layered on top of the actions, we've got a number of Mistral workflows, and these are just YAML documents, quite similar to workflows defined for Ansible, really. It allows you to define, the sequence of steps and any kind of like action you need to do on success or failure associated with, say, deployment. And so those are kind of concepts to be aware of. And this picture has got Zakar, which is providing kind of a messaging channel for those workflows to signal progress and or success failure to the user interfaces. So this is just kind of like a quick 101. I might maybe drop to a shell in a minute and just demonstrate some of these. But if you're coming in to use Mistral for the first time, which I was quite recently, this is kind of a cheat sheet which you might find quite useful. So as I mentioned, all of the actions that we deal with are basically Mistral actions, and if you just do Mistral action list, it gives you a big long list of all of them. If you grep for TripleO, then you'll soon see the TripleO specific ones, and those basically relate to the Python plugins that are defined in TripleO Common repo in the actions subdirectory. One trick which I thought I would mention is sometimes you find that the TripleO or any of the action plugins don't register properly, and there's a nice setup tools utility called Entry Point Inspector, and I've been using that a bit recently. Basically, if you go EPI group show, it shows you the setup tools entry points, and so the Python plugins that are used by Mistral are basically defined as setup tools entry points, and it gives you a nice long list of all of the entry points setup tools knows about. And also there's like a column which shows you if there's an error. For example, if there's a syntax error in one of your plugins, it won't register properly, and Mistral won't show it to you via action list. And another step to actually register those Python plugins is Mistral has a db manage populate command. Mostly you don't have to care about that unless you're hacking on the plugins yourself. But normally when you do an Undercloud install, Puppet just runs that command for you and populates all of the TripleO actions. And then layered above that, you've got Mistral workflows. And so again, we've got some TripleO specific workflows which are defined in TripleO Common, and they actually get installed under user share TripleO Common workbooks, and so you can have a look and sort of see what those workflows look like. So you can you can dig under the hood and see what's actually happening, and you can also run those manually. So it's quite useful for debugging if you want to run a TripleO action standalone, because maybe you suspect that it's doing the wrong thing during during a deployment. You can just do Mistral run action. You can also do an execution of a workflow manually via Mistral client. So hopefully that will be kind of a useful, just to bootstrap people into playing with Mistral a little bit and give you a bit of a better visibility under the hood in terms of what's happening when we start using Mistral workflows for most of the deployment workflow pieces. One last thing is I mentioned we're using Swift to store data associated with deployments. If you do Swift list, as soon as you start doing Mistral-based deployments, you're going to see, say, an Overcloud container, and that's basically just a container for the templates and some environment-based data that is used for the deployment. So rather than deploying from a local file directory where you do OpenStack Overcloud deploy minus templates, now it's basically being pushed into a Swift container. So that's a good way if you want to sanity check the version of what's being deployed. You can just have a look straight into Swift, do Swift download Overcloud, and it'll just pull down all the files for you. So that was just a quick overview of Mistral. Were there any questions on that before I move on? Okay, we can always circle back at the end. So now I just wanted to move on to talking a bit more about the Undercloud install process. I'm going to keep this fairly high level because I think James is going to get into a bit more detail on this. But basically, I just wanted to sort of visualize the process. So when you go to install your Undercloud for the first time, or when you do an update where you can rerun the OpenStack Undercloud install command, basically the OpenStack Undercloud install command is Python TripleO client. We have a TripleO client plugin for OpenStack client, and inside there is the code that runs the Undercloud install. And that's influenced by an Undercloud configuration file, which again, I think we're going to talk about in a bit more detail later. And then Python TripleO client basically references some code in the instack Undercloud repo. Again, there's a Python module in there which defines exactly what happens during the Undercloud install. And then underneath that, you've kind of got two distinct phases. You've got instack, which I think James is going to talk about a little bit, and some disk image builder elements that are applied onto the local box. And then you've got OS refresh config, which runs some scripts, which include supplying Puppet on the local box. And so the majority of the work here is basically done by Puppet, and there's a little bit of glue logic basically to convert user options from undercloud.conf into Huayra data for Puppet. And then once that's all done, you've got all of your OpenStack services up and running. Your networking should be configured. And again, we'll talk about that a bit more later. And you should be ready to go, upload some images, register some nodes, and do your Overcloud deployment. So that's hopefully a reasonable sort of overview of how things work. And then here it's a bit of a wall of text, I suppose. It might be better for me to drop to a console. But basically, yeah, we've mentioned that it's in the Undercloud, Instack Undercloud repo. Basically, we do use some PyStash templating, which basically it mangles the user options from undercloud.conf into values that are templated into a YAML file that is consumed by Huayra. There are a couple of things that aren't configured via Puppet, so you kind of need to watch out for those. They're not very many now because I know James did a ton of work moving things out of Elements and into Puppet, but in particular stuff like the iPXE configuration as of right now is still done via a script, which is driven by an element. And so when I'm debugging things, I tend to end up looking at these two scripts, which you can basically look at on the Undercloud. We'll have a quick look at it in a minute, and then I'll pass over to James. But basically, 50 Puppet stack config, this is the script that runs Puppet. By that time, the Huayra data has all been put into place. And then if you find that, say, sometimes I find that the Undercloud install will get hung for some reason, and I don't know why. Normally, my debug workflow will be to go and run this script manually, and quite often I'll edit it to just put minus debug in, so Puppet will give me a bit more verbose output. So we'll have a quick look at that in a second. And then 98 Undercloud setup increasingly has less logic in it than it once did, but this is basically a script that runs at the sort of post-installation phase and does a few actions which are not handled by Puppet. Things like, for example, registering the Mistral workbooks are currently done in there, and a few other things. So there are a few other pieces. I mentioned the iPixie, and there's a few other scripts, but those are the two that most often I end up having to debug. So we'll just have like a quick look at some of those on Undercloud, and then I'll pass over to James to talk about the process in a bit more detail. So I'm just going to switch to a different screen. So can you guys see this this terminal okay?
Yeah, we can see it. You might want to make it a little bit bigger if you can.
Yeah, sure. How's that?
That's good.
Okay, so yeah, we talked a little bit about the pieces that make up the Undercloud install. I'll just quickly go through those kind of more or less in the same order that they were on the diagram. I won't go to the TripleO client. I'll start at the Instack Undercloud layer. So in Instack Undercloud, here we have an elements directory and an Instack Undercloud directory. If we look in Instack Undercloud, there's this undercloud.py file. This is basically where the bulk of the logic around Undercloud installation is defined. And so you can see in here, there's a bunch of different options. So network gateway is an example, or Undercloud service certificate. Basically down here, we have this transformation that happens to all of the options basically get switched into environment variables, which ultimately get consumed as part of the PyStash context. And that really means that they get translated into a Huayra data file. So we can have a look at an example of that. So this is the Puppet stack config element, and then there's a template file, and you can see there's a bunch of so you can see here Undercloud service certificate in capitals. So for example, that configuration option that we just looked at is going to get basically pasted into here via the PyStash substitution that happens. And then there's also this Puppet manifest. So this is where the majority of the logic performed by Puppet is defined. So you combine that with the Huayra data from that YAML file, and that defines what happens when you run Puppet. So what normally happens is every now and again you'll need to make a change to that, and you need to test it locally. So the way I approach doing that is if you look in user libexec, refresh config, configure D. So again, I haven't talked about all of these other scripts. I'm just focusing on kind of the Puppet one for the time being. Yeah, if we look in here, that's basically the Puppet apply that happens. So you can either run that manually, or you could just run the script. Doesn't really matter. So let's say I'm going to run this, but I want a bit more information. So that's kind of the debug workflow that I would go around if I think that something's going wrong, or if I need to make modifications to that Puppet manifest. Just have a quick look at my notes, because I think there may be another couple of things I was going to talk about. So yeah, let's just have a very quick look at Mistral, and then I'll pass over to James. So here we can see, here's all of the different kinds of Mistral actions, and you can see there's a whole ton of different stuff that is built in. If we filter that for TripleO, you'll see that there are these different different actions, and you can actually run those. So if you do, let's say we're going to run the TripleO list plans action, That just runs and it gives you the result right there. You can also run a workflow. So if we have a look at so we've got this plan management workbook. As I said, it kind of looks pretty similar to some Ansible workflows. And we've got this create deployment plan workflow. If you do Mistral workflow list, you can see here we've got this plan management create default deployment plan. That's basically this workflow here. And so it's going to create a Swift container. It's going to upload some stuff to the container, which is the heat templates, and basically signal on success. So that's the overview of what happens. And you can just run that via a Mistral execution like this. So and you pass inputs on the command line. I've just done a typo there. So you can see there that's actually run. And there's the overcloud foo. And if you want to see what's in there, you can just create a temporary directory and download it all from Swift. And as you can see, that's basically the TripleO heat templates they use for deployment. So that's pretty much all I had. Are there any questions about that before we move on and I hand over to James? All right. James, do you want to share your screen with the slides, or do you want me to just...
I'll go ahead and share.
Okay, thanks.
Okay. All right. So yeah, I was just going to show a couple more things here, just kind of build upon what Steve showed. I wanted to talk a little bit about how Instack is driven a little bit more, and then how you can further customize the Puppet and networking configuration during the Undercloud install if you need to. So this is just a git checkout here of Instack Undercloud. Can you guys see my terminal all right? Is it big enough?
The font looks a little bit angled. I'm not sure.
Yeah, I might want to make it a bit bigger.
I can make it bigger here. Is that any good? Is that better?
It's probably more my screen than your screen.
Okay. It might have something to do with the font I'm using. Is it clear for anyone?
I can make it out, James. So if it's just me, don't hang on that.
All right. Let me try switching to a different font real quick. All right.
Oh yeah, perfect.
Yeah, that's better.
I think it has something to do with that bitmap font, to be honest. I noticed that before on Blue Jeans. So anyway, okay. So Steve already showed this file, but there was just one other additional thing I kind of wanted to show. So if we open up the undercloud.py Python file, this is 1,000 lines or so for better or worse. But I think this is pretty easy to kind of reason logically about. If you jump down here to the install function, which is kind of the driver for this whole program, you can kind of see the linear flow that we do. So it's, load configuration, and then we do a little bit of cleanup here in the generate environment, and some of the transformation stuff that Steve was showing earlier. And then we get down to where we actually run instack. And then after that, we run OS refresh config, which Steve showed, and then we do a little bit of post configuration as well. So there, it's a fairly long program, but there isn't really a lot going on here. I think it's pretty easy to understand if you just kind of start here and kind of use this to kind of jump around and see what might be going on. So if I just go up here and look at the run instack function, you can see that we're calling instack, and instack is actually another Python tool which is kind of driven by the elements, which are typically a set of bash scripts to kind of do system configuration. They're primarily used for disk image building, but in this case, we're using them to kind of apply changes directly to the Undercloud system itself. And this is actually, and instack actually takes as input a JSON file, which has a list of elements in it that we're going to use to do the install. So if we take a look at those JSON files real quick. And this is the one we use for CentOS 7. This is actually the list of elements that we're using to install the Undercloud in this case. So it's a pretty small list, and these pull in a couple of additional dependencies as well. But, as Steve mentioned, we're trying to move away from using these and more towards Puppet. So we keep putting more and more of this functionality into this single Puppet stack config. And kind of once everything's been switched over to that, in theory, we could then get rid of instack entirely and just use Puppet to apply the whole installation. So yeah, I just wanted to show that JSON file real quick and kind of what's driving instack and where the list of elements comes from. All right, let me go back to the slides real quick. So I think this might have been one of your slides, Steve, actually. I think you kind of already talked about that. So yeah, the customizing the config, we have the undercloud.conf file, and there's a couple of options in there that I wanted to show that we recently added because I think they're pretty useful. The first is this Huayra data override, and this allows you to set any Puppet Huayra data, and that's going to basically influence the configuration that's applied by Puppet. So you can set any Huayra data that the Puppet modules expose, and the Puppet modules themselves actually have some open-ended interfaces as well, like nova_config would allow you to define any configuration option in nova.conf, for example. So it's pretty open-ended what you're able to do with this. And part of the reason we added this is that you don't have to keep gratuitously adding new options to undercloud.conf. I think we can continue to add things there for the most frequently used options, but obviously it's not really going to scale to add every single OpenStack configuration option to that single config file. So this Huayra data override will kind of an open-ended interface to let you configure anything at all. And then additionally, we have the netconfig override, and this will allow you to specify a different template for OS netconfig to apply a network configuration to the Undercloud. And OS netconfig is just the networking tool that we use to configure networking on the Undercloud and the Overcloud. It uses a declarative approach to kind of describe the networking setup that you want to apply, and then it persists that configuration via IFCFG scripts, or for like Debian or Ubuntu-based systems, it also has the ENI backend as well. So here's a couple links here, but I'll go ahead and show what I wanted to show here was the samples directory out in OSNetConfig. So we always try to add a sample here every time we add some new support for a new interface type to OSNetConfig, and this will kind of give you an example of some of the things that you can do. So if I just bring up, go down here to, like, I'm trying to see like where the OBS bridge is. If we just bring up like the bridge in DHCP, this is actually pretty close to the default configuration that we're going to use on the Undercloud. So you can see we just have some YAML here. And we define an interface of type OBS bridge and give it the name BR control plane. And then that bridge will have the following members, and EM1 is going to be a member on that bridge. A bunch of other things out here as well, like OBS Patch Ports is one thing that I added to connect to OBS bridges. I thought that was kind of useful for something I was doing at the time. So that's kind of an example of how you might do that. You can see we're building a bridge here with ETH1 as the member, and then we're adding two OBS Patch Ports. And these two ports connect BR control plane and another bridge called BR pub, which is actually not defined in this example. That kind of gives you an idea of how OSNetConfig configures networking. I think we'll probably do another deep dive in the future on networking in more detail, but I just want to show it briefly because we do use it on the Undercloud as well. And not everyone's aware of how much configuration it actually provides for you to do. So if I just jump back here to my Undercloud here, which is already installed, I just installed it with all of the defaults, but I wanted to show kind of setting these two override options and the effects that they have. So I have a couple of files out here. One's called mycustomhuayra.yaml. And what I've done here is I have set this Huayra data option ironic enabled drivers, which is basically going to configure what power and deploy drivers are enabled for ironic. So by default, we actually have several drivers enabled, but if you only want to have the IPMI tool driver, you could use this Huayra to do that. So I'm just going to show by default, we have all these drivers enabled. And when I set this Huayra file, I should end up with only the IPMI tool driver enabled. And I also have an override file out here for a network configuration. And it's called netconfig with external vlan.json. And so yeah, this is kind of the default configuration here for the Undercloud. So I've duplicated that into this JSON file. So I'm still building a bridge called BR control plane, and I'm adding an ETH1 interface to that. And then I'm adding an additional port for VLAN 10 here. So if you recall in the debugging deep dive I did, I don't know if that was last week or 2 weeks ago, to be honest, but one of the things I showed was how you have to add an external interface to your Undercloud if you're using network isolation so that your Undercloud can reach the overcloud over the external network. And in that case, I was using VLAN 10 in that example. And I actually just ran the commands on the command line to create this VLAN 10 interface and assign it an IP address and whatnot. And that certainly works. The issue with doing that is if you reboot your Undercloud, you've lost that unless you go out there and write, or write your ifconfig scripts manually or something. So what I want to do here is I want to go ahead and define this interface via OSNetConfig so that it'll be persisted in the Undercloud configuration. It'll survive reboots and OBS restarts and all that good stuff. So add these two. I forget these file names, so go ahead and copy one of them at least. Oh, I want to add one for the netconfig override. One out here for, I think this was my custom Huayra.yaml. Before I kick off the install again, to show my current networking configuration, I don't have that VLAN 10 interface defined. And it's not defined in OBS either as a port on BR control plane. But it should be after I rerun the install here, so I will go ahead and do that. So a lot of the initial output you see when you run this is from Instack, and then things are a little verbose as we run some bash scripts still. So those are a little, they produce a lot of debugging and tracing output for better or worse. But a lot of the changes we made in Newton is to move more and more stuff to Puppet. So one of the things you might notice is you're going to get into the Puppet install much sooner now than we used to. A lot of the package installs and more configuration is all happening via Puppet now. All right, so it's compiled the catalog, and one of the first things it should do is run os netconfig, which you can see the output right there. So that returns successfully. I'm just going to jump down to another here, and I should now already have that interface defined out here, and I do. You can see it out here now. So I've got this VLAN 10. And it should be in OBS as well, which it is. And again, you know, one of the nice things about OS netconfig is how it persists the configuration. So right, so that's the file I actually ended up writing. You can see we drop a little comment in these files so that folks are aware. If you go out here and you make some manual edits, the next time you run OS netconfig, it's probably going to blow that away. So, but that kind of shows how you can really customize any networking setup you want on your Undercloud using this. That's supported by OS netconfig. It supports quite a bit. And then if this, depending on how long this takes here, I can try to show that it has reconfigured the enabled drivers in Ironic. Sometimes this takes a minute. I know this is not going to work now because Puppet's actually restarting Apache currently, so I'll let that finish first. Otherwise, I'll probably get a Keystone error. Any questions or anything? All right. Yeah, so we're still in the middle of kind of restarting services, so that was probably not going to work. But I should move on shortly here. That's about all I wanted to show, really. I think that, yeah, if you want to know more about OS netconfig and a lot of how the networking configuration works for the overcloud as well, I think we'll try to do a deep dive on that. Let me just show one thing real quick, just to kind of try to tie some concepts together. I just go out here to TripleO heat templates. So for the overcloud, if you're familiar with the networking configuration, how that gets applied, you know that you can pass various templates to configure your networking. If we open up one of those, so this is actually a heat template, but inside the heat template, we're actually building a resource called OS netconfig implementation. And we have that exact same YAML kind of embedded in the heat template here. So this maps directly to an OS netconfig configuration. So that should hopefully give you an idea of kind of how to drive OS netconfig for the overcloud as well. So I believe I moved on. Let's see if that did what I expected. And there you go. So yeah, I just reconfigured the enabled drivers. Yeah, kind of a simple example, but you know, the Huayra data is really exposes pretty much anything for you to configure how you need. Let's see. I think that's about it that I wanted to show. We've got a couple slides left here, and we'll put the link to the slide deck into the Etherpad. Yeah, just some standard links here as well. All right, cool. Steve, you got anything else to add, or are there any questions?
Carlos has got one question in the chat, which was about testing Undercloud changes. So I guess we could talk about that a little bit. I mean, my approach is generally to use TripleO.sh -minus DeLorean build, and then build a package and either install it with sort of yum local install, or if I want to ensure it doesn't get accidentally modified during the Undercloud update, then I might create a local repo and just make it priority 1. And the other way is with Puppet. You know, obviously, if you're modifying the Puppet stack config manifest, you can just hack on that directly and keep testing Puppet manually, as I demonstrated earlier, until it works. And that includes if you needed to, say, update one of the modules, you could also have a git checkout and temporarily just kind of hack the configuration on the Undercloud node. But James, did you want to maybe give your thoughts on that? Because I know everyone has different approaches to these things.
Yeah, so typically what I'll do is if I'm testing changes to Instack Undercloud, I will usually just kind of hack directly on an Undercloud, and I'll have a git checkout on the Undercloud, and you can pip install Instack Undercloud on an Undercloud, but the one thing you have to watch out for is how we use data files in a setup config. So we use data files here in the setup tools configuration to install the elements and the JSON files and the templates as well. And the templates are just the OS netconfig templates. But pip can be a little flaky with how it installs the data files. It doesn't always overwrite if they're already installed. So just watch out for that if you are like, you know, if you do pip install Instack Undercloud and like, you know, edit mode or something, I don't think it even symlinks the data files correctly. So that's one thing to kind of watch out for. But if you're kind of hacking on the Python code, then yeah, you could use pip install to install that in edit mode even, and that works fine. Yeah, you can use the DeLorean build locally. I don't use that a lot, but I have in the past. And then, of course, if you want to test out a change to a Puppet module, the Puppet modules are on the Undercloud under etc Puppet. So you can, you know, if you even want to totally test out a change here to like the ironic Puppet module, you can make a change here and then rerun the Undercloud install as well. And that's a good way to test as well. So. All right, cool. Any other feedback or questions? Anything else I can show you guys since we got a few minutes left? Not we'll just end early.
Just to draw attention, if anyone hasn't seen it in the chat, Ben has posted a link to automatically built packages for under review code, which is pretty handy as well if you don't want to have to build the packages locally yourself.
Ben, are you building that for every single patch? And maybe he didn't have his microphone on. Yeah. All right, cool. All right, if there's no other questions, we'll go ahead and wrap up, I guess. Yeah, let me know if there are any further topics for next week or anything else that everyone would like to see, and we'll try to cover as many of these topics as we can. So, all right, thanks for joining, everyone.
Thanks, everyone.
Thanks, guys. Cheers.
Thank you, guys.
Thank you.